So far in this part, all we've done is graphed nonlinear functions or absolute value inequalities. This last task, we're going to be doing some algebra and solving real-world applications that involve absolute value inequalities. So let's look at an example. The company's target sales goal is $140,000 for a certain quarter. It will consider that it has met its target if it is within $12,500 of the goal. Find the range of values that will be considered meeting its target. Now, underline this phrase within $12,500 because that is what tells me that we're dealing with an absolute value inequality. Another way of expressing within $12,500 mathematically would be to say we need something to be less than or equal to 12,500. Right? That's what the word within means. It means close to. And so what is it we need to be within 12,500? We need the sales to be within 12,500 of the goal, 140,000. So what does that mean mathematically? Well, the sales, we don't know what the sales are, so that's going to be our variable. And then the goal is 140,000. So we need the actual sales and the goal to be close to each other. And how do we measure how far apart they are? Well, that is what subtraction does. And so we need the difference, x minus 140,000. We need that difference to be within $12,500. Now, the problem with my inequality so far is that if x were really, really small, then this is still going to be less than 12,500. So really what within means, it doesn't mean just less than, it means that the absolute value of the difference needs to be less than that, because absolute value is going to turn a negative into a positive. And so x could be a little bit above 140,000, a little bit below, and the absolute value is going to make them equivalent in terms of the difference. So that's the first part. That's how we set up the absolute value inequality. The second part is going to be solving this. So to solve this, what we have to do is, there's going to be two different ways of solving. So the first way is when you have a less than, then there's going to be this way of solving. And then we'll see in the second example what you do when you have a greater than. So in the case of less than, what you have to do is you take your expression inside the absolute value, and we know it needs to be less than that number. But since it could be negative, it could also needs to be greater than the opposite of, in this case, 12,500. So that difference needs to be basically in between these two numbers. And so then, once we've set it up like this, all you're doing is you're solving to get the x alone. And so I need to get rid of this minus 140,000, so I'm going to add that there, but then I've got to add it over here as well, and then I've got to add it over here. And so that cancels, and so I'm left with x. I'm running out of space, but this is going to be my solution anyway, so that's okay. So x needs to be greater than, and so I'm going to plug in my calculator, negative 12,500 plus 140,000, and so I get $127,500. And then over here, x also needs to be less than 12,500 plus 140,000. So that's going to be $152,500. And so then this is my range of acceptable target values. And if you think about it, that makes sense. So if the target, it could go a little above 140,000 and it could go below, but it needs to be in that range in order to be considered meeting its target. So let's look at one more example. This one's going to be a little bit different. So example 2, the ideal weight of an iPhone X, or iPhone 10, is 6.140 ounces. This weight can vary by 0.002 ounces, and anything outside this range is considered defective. So I'm going to underline outside this range, and so that's already cluing me in that it's going to be an absolute value inequality. And then we want to find the range of weights for defective iPhone Xs. So outside this range is going to change things up, because now we're not talking about less than or equal, we're talking about greater than some value. What value? Well, it can vary by this value. So I don't want, well, any phone that's going to have a bigger difference between the actual weight and what it's supposed to be, more than this, is going to be defective. It's going to be either too heavy or too light. So then again, over here on the left, I want to have my variable. So in this case, what we're not sure about is what the actual weight of a particular iPhone is. And we need the difference between that and what it's supposed to weigh to be bound in a certain range. And so then in this case, again, we don't want it to be too high or too low, so we add in absolute value symbols, because that says that difference needs to be not too high or not too low. Except, in this case, the way I've set it up is we've got greater than, so we're actually trying to find which x values are going to be outside the acceptable range. So that's this defective iPhone, so it's the opposite of before. So in this case, to solve, when you have greater than, this is going to be a little different. So you got to take note of what symbol. So in the greater than case, we're going to set up two different inequalities. We're going to say either this difference needs to be more than the range, or less than the opposite. Ooh, running out of space. Okay, so you'll notice some commonalities before. We take this value and then we use its opposite in the other one, and then we flip the sign. But now we're solving two separate inequalities. And so our range is going to be also two separate inequalities. So I'm going to start with this one over here. X minus 6.14 is greater than that. So I got to add this to get the x by itself. I'm going to do that on both sides. So then I'm going to go down in the space below since I ran out. X is greater than, and then if I add 0.002 and 6.140, I get 6.142 ounces. I like to add the units since we're doing real world problems. Or, I got to do the other half. In this case, if I add, I'm doing the same operation on both sides. So then I get x less than, and then if I add negative 0.002 to 6.14, I'm going to get 6.138 ounces. And so this makes sense because, again, I'm looking for defective iPhones, and so either ones that are too heavy on the left, that's not okay, or ones that are too light on the right, that's also not okay, because maybe that means they forgot to put a part or something. And so that's how we do absolute value inequalities.